life. NASA analyzes a molecule from a distant planet that on Earth is only produced by living beings. K2-18b orbits a small cool star shown in red, far enough away for its temperature to support life. September 12, 2023. A NASA telescope may have discovered possible evidence of life on a distant planet. This is because a molecule called dimethyl sulfide, DMS, may have been detected. At least on Earth, this is only produced by living organisms. The researchers emphasize that this possible detection on the planet 120 light-years away is not robust, and more data is needed to confirm its presence. The discovery was made by NASA's James Webb Space Telescope. Researchers also found methane and CO2 in the planet's atmosphere. The detection of these gases could mean that the planet, called K2-18b, has an ocean of water. Professor Niku Madhusudhan of the University of Cambridge, who led the research, told BBC News that his entire team was shocked when they saw the results. On Earth, DMS is only produced by life. Most of it in Earth's atmosphere is emitted by phytoplankton in marine environments, he said. Precaution: the James Webb Space Telescope is capable of analyzing tiny particles of light from the atmospheres of distant planets, but Professor Madhusudhan described the DMS detection as tentative and said more data would be needed to confirm its presence. These results are expected within a year. If confirmed, it would be a huge discovery, and I feel a responsibility to get it right if we are making such a big claim. It is the first time that astronomers have detected the possibility of DMS on a planet orbiting a distant star, but these results are treated with caution. This is because a statement made in 2020 about the presence of another molecule, called phosphine, which could be produced by living organisms in the clouds of Venus, was challenged a year later. Even with this scenario still uncertain, Robert Massey, an independent researcher and deputy director of the Royal Astronomical Society in London, said he was excited about the results. We are slowly moving towards the point where we will be able to answer the big question of whether we are alone in the universe or not, he said. I'm optimistic that one day we will find signs of life. Maybe with this current discovery, maybe in 10 or even 50 years, we will have such convincing evidence that it can be better explained. The telescope responsible for the possible discovery, the JWST, is capable of analyzing the light that passes through the distant planet's atmosphere. This light contains the chemical signature of molecules in its atmosphere. Details can be deciphered by splitting light into its constituent frequencies, rather like a prism creating a rainbow spectrum. If parts of the resulting spectrum are missing, it will have been absorbed by chemicals in the planet's atmosphere, allowing researchers to discover its composition. The feat is even more remarkable because the planet is more than 1 quadrillion kilometers away, which means the amount of light reaching the space telescope is minuscule. Like DMS, the spectral analysis detected an abundance of methane and carbon dioxide gases with a good degree of confidence. The proportions of CO2 and methane are consistent with the existence of an ocean of water beneath a hydrogen-rich atmosphere. NASA's Hubble telescope has detected the presence of water vapor before, which is why the planet, called K2-18b, was one of the first to be investigated by the much more powerful JWST. But the possibility of an ocean is a big one step forward. Recipe for life. A planet's ability to support life depends on its temperature, the presence of carbon and probably water. The JWST observations seem to suggest that K2-18b meets all of these requirements. But just because a planet has the potential to support life doesn't mean it will, which is why the possible presence of DMS has such an impact. What makes the planet even more intriguing is that it is not like the rocky, Earth-like planets discovered orbiting distant stars that are candidates for life. K2-18b is almost 9 times the size of Earth. Exoplanets, planets that are outside the solar system, that is, that orbit other stars, with sizes between those of Earth and Neptune, are different from anything that exists in our solar system. This means that these sub-Neptunes are poorly understood, as is the nature of their atmospheres. According to researcher Subhajit Sarkar of Cardiff University, who is another member of the team that analyzed the data, although this type of planet does not exist in our solar system, sub-Neptunes, with a mass less than giant Neptune, are the most common type of planet known so far in the galaxy, he said. We obtained the most detailed spectrum of a sub-Neptune habitable zone to date, and this allowed us to discover the molecules that exist in its atmosphere.